All right, today we are cracking a code. Not just any code, but a fundamental rule that governs our entire universe. And it might look a little intimidating at first, but trust me, it reveals a simple, absolutely mind-bending truth about reality itself.
So, this is it. This little line of symbols is Heisenberg's uncertainty principle. And I know, it looks like something out of a physics textbook. But this right here, this is one of the most profound statements about reality ever discovered. Think of it like a non-negotiable rule from the universe's own operating manual. And together, we are going to decode exactly what it's telling us.
So, first things first. To crack any code, you have to understand the symbols, right? So let's break this thing down piece by piece.
Okay, first up, we've got this little triangle x, or delta x. This stands for the uncertainty in a particle's position. And the key word here is fuzziness. Now, I'm not talking about a blurry photo. This means, at the quantum level, a particle doesn't actually have one single definite location. It's inherently spread out, existing in a range of possible places all at once.
Next, we've got delta p. That's the uncertainty in momentum. And, momentum is really just a fancy way of talking about an object's speed and its direction. And just like with position, a particle doesn't have one single clear-cut momentum. It's a blur of possibilities, a fuzziness of both how fast it's going and where it's headed. And finally, there's the other side of the equation, that h bar over 2. Now, this isn't just some random number. It's a fundamental constant of nature. It's a hard limit. It represents the absolute, non-negotiable, minimum amount of uncertainty the universe allows. You literally cannot have less total uncertainty than this tiny number. It's like the universe's minimum pixel size. You just can't get any sharper.
Okay, so we've got our pieces. Uncertainty in position, uncertainty in momentum, and a cosmic limit. So how do they all fit together? Well, the best way to picture it is to imagine a cosmic seesaw. This really gets to the heart of it. Imagine position is on one end of the seesaw and momentum is on the other. If you manage to pin down a particle's location really precisely, basically pushing that side of the seesaw all the way to the ground, the other side has to fly way up. The more you know about where it is, the more uncertain its momentum becomes.
And of course, the exact opposite is true. Let's say you measure its momentum with incredible accuracy. You know exactly how fast and in what direction it's moving. Well, you've just slammed the momentum side of the seesaw down, and whoosh, the position side flies up into the air. You now have almost no clue where that particle actually is. You can know one, or you can know the other, but you can never, ever know both with perfect certainty.
Now, this is where the biggest misconception usually pops up. Your first instinct is probably to think, okay, so this is just a limitation of our tools, right? Something we'll figure out how to fix one day. But that's not it at all.
I mean, it's a totally logical question, right? You might be thinking, surely if we just invent a better ruler or a more sensitive measuring device, we can measure both at the same time and get around this rule.
The answer, and this is the really mind-bending part, is a simple and profound no. This isn't a limit on our technology. It's a fundamental, baked-in feature of reality. A particle doesn't have a single precise position and a single precise momentum at the same time for us to find. The uncertainty is part of what the particle actually is.
And this isn't just some weird, abstract idea. It has real-world consequences we actually use. For instance, those incredible scanning tunneling microscopes that let us literally see individual atoms, they only work because of this principle. They use that probabilistic fuzz of where an electron might be to map a surface. So this strange rule isn't a barrier, it's a tool. And embracing it forces us to completely rethink our picture of the universe.
For hundreds of years, we saw the universe as this giant, predictable clockwork machine. If you just knew where all the gears started, you could predict the future perfectly. But the uncertainty principle completely shatters that idea. It shows us we live in a probabilistic universe, where you can never know the exact state of things, only the likelihood of different outcomes.
I mean, the fallout from this one little equation is just staggering. It tells us the universe isn't some predictable machine. It tells us that at its deepest, most fundamental level, reality is a game of chance. The absolute certainty we feel in our day-to-day lives, it's kind of an illusion, just the average result of countless quantum probabilities. It tells us that uncertainty isn't a flaw in the system. It is the system.
So, that leaves us with a pretty deep question to chew on. If the very fabric of reality is woven from uncertainty and probability, not from hard and fast certainty, what does that mean for the certainty we're always searching for in our own lives?
It suggests that maybe the universe is less like a finished book and more like a story that's still being written, one quantum roll of the dice at a time. It's something to think about.